I was a math major at TCU. I always wanted to teach high school math. That was the goal. So I double majored in math and secondary education. And throughout my undergrad experience, I realized there was like a huge controversy about whether or not graphing calculators should be allowed in the classroom, specifically on tests. And so while I was student teaching my last semester of my senior year at Aledo High School, I really took note of like the benefits of graphing calculators and also the disadvantages of them, and I just decided to make a project comparing my experiences to the research I found about them, and ultimately came to the conclusion that they are beneficial in the high school math classroom and for various reasons. But yeah, that's kind of what drove my interest towards it. First thing I did, well, first I was in contact with two of my professors, Dr. Switzer and, Dr. Switzer and Dr. Alexander, who both, told me to hone in on my interests. And then I just started with like a literature review. So I browsed through the TCU library and Google Scholar for just any studies on graphing calculators and their use in the high school math classroom. So I kind of just synthesized my literature, and then from the student teaching experience, I actually interviewed a few students about how they feel about graphing calculators. I did my own observations about how they were utilized in the classroom, and then I also took note about test scores with calculators and test scores without. So it was kind of a double research process with my own experiences and then the research that already exists.
Mm-hmm. Okay, cool. Sorry, I'm trying not to. You discovered?
So I think one of the biggest challenges with graphing calculators is that people think that they take away the mathematical kind of like computational process because they have capabilities that people think students should be able to do on their own without a calculator. However, I think teaching and education is drifting way more towards differentiating instruction and individualizing it for each student. And the benefit of a calculator is that if a student can't understand something just through the visual kind of representation, graphing calculators have the ability to graph it. They can symbolically show it. You can see it in many different representations, and that's helping a lot of students just being able to visualize the mathematics instead of kind of just having the equations. And I think the other thing that I realized is that I was teaching a calculus class, and if I spent the majority of the time going over the computational aspect of it, so like the simple like multiplication or just the algebra that goes into it, we would have spent the whole class period doing that and never getting to the calculus concepts. So what the graphing calculator would do was facilitate those computational things that the students really already know how to do, so that we could dig deeper into the actual more complex math. Focus on graphing calculators, I wasn't really sure which direction I wanted to go, I didn't know whether they were going to be beneficial or detrimental until I really started exploring. But I do think I was surprised by how well the students reacted when I was interviewing them to using graphing calculators. And then when I would kind of test out lessons without using them, like how kind of horribly they would go, just because when students have to go through like a long computational process, it's almost like they just give up. And then when you actually get to what you want to teach, they're like, no, like we already did all of this, we're not going through. So it really helped that like efficiency aspect, which I wasn't necessarily expecting. And then, like I said, the students also commented that they were able to use the graphing calculators to double check their work, which gave them more confidence, because they realized, okay, I'm doing this right, or maybe I'm doing this wrong, but then using the calculator to kind of figure out how they were doing it wrong. So it was a lot more beneficial than I expected, just because of the controversy I know exists. I was hoping to see more of like a, balanced scale, but it seemed to be that they were more advantageous than anything. So I will say there aren't a lot of students that don't want to use the graphing calculator, just because it just helps them move quicker. But I guess I would just show them the benefits that a graphing calculator can have, specifically as far as that multiple representation. So a lot of times students will just be stuck on an idea, can't get through it, but then maybe I'm looking for x-intercepts and I just give them an equation and tell them to solve where y equals 0, and they don't understand what that looks like. Then I can actually graph it and say, look at these points where y equals 0, that's what you're looking for. And that kind of helps them get past that, equation, math, word that they can't really decompose in their head, and helps them move forward when they can see it in kind of a different representation. I think it really helped me propel my career as a teacher, because whether or not a teacher uses a graphing calculator or any technology in the classroom is a huge decision, and you kind of have to, before you start teaching, figure out what are the benefits, what are the disadvantages, because technology sometimes can overwhelm the classroom and take the role of the teacher. So I think by doing the research and really figuring it out before I started teaching, now I know the benefits, and I also know when not to use a graphing calculator, when the student should be able to do things by hand, and when they kind of take over that mathematical process, which I don't want. So I think it was really helpful to explore that, and it helped me get a lot more out of my student teaching experience for sure. Yeah, so I think it's just you really have to sit down and kind of investigate and kind of be the judge about whether or not they're helping or harming the students, because I think a lot of times we're like as teachers go, it's kind of like, okay, yeah, you can use your graphing calculator, but you're not really thinking about what the use is, what a student can do with that, what it can take away from the mathematical process. So I'm really glad that I actually sat down with the students and got to talk to them one-on-one about how they are using it when they go home and do their homework. Are you pulling out your graphing calculator, typing in the equation and getting an answer, or are you doing the homework and using it to check your answer, using it to see something visually, all the benefits of it. So I think I paid much closer attention to it than I would have without the research. I would say for advice, just make sure that, especially on testing and things, a lot of times I had problems where the students wouldn't show any of their work, and I was like, okay, how did you get these numbers? Especially that x-intercept problem I was telling you about. They would write down the 3 points, and I'd be like, where'd you find those? And they're like, I saw it on my graphing calculator. Okay, well, you need to explain to me why those x-intercepts make sense, how you could solve it by hand, and those kind of things. So just making sure that they have that conceptual understanding as well as the knowledge of how to use the graphing calculator. Most challenging, I would say, is the students' resistance to do things by hand when they know there is an easier, faster way using the technology. And that's where, as a teacher, you really have to decide, okay, is it worth it to really go through and make sure my students can do this by hand, or is a calculator the way to go? Because I think a lot of people would argue now that multiplication, division, all of those things, we don't necessarily, they're not as important to be taught in school anymore because we have calculators that can do it for us. So when I was teaching high school math, I really thought about the concepts, and I thought about how they would build on later concepts. Do the students really need to know this concept, or is it kind of a something that they can use the graphing calculator to help facilitate it? And so when planning, I really thought about whether the concept would appear later, again, that they're going to have to know how to do it, or if the graphing calculator was the better way to go. But I definitely got students were resistant when they knew that there was a simpler, faster way to do it. So you just kind of have to explain that it's important to know the process because it will appear later on, or you'll use it in life. So that was kind of where the battle was. So I am doing my master's right now in math education, and so I have another thesis coming this year, and it's going to be about analyzing data in the classroom, so teachers, data-driven instruction. I'm actually going to create an undergraduate course that all education majors are required to take, and it's going to teach statistical skills and data analysis skills for educators, because I found that there's a huge gap between teaching and then data analysis. So the math department is always like gung-ho about it, ready to go, ready to look at all the results and figure out how they can teach better. But then you look at the other departments and people that are more afraid of numbers, and they kind of resist looking at the data in order to improve their instruction. So I just think it's really important that everyone has a foundation in statistics, everyone knows how to do a basic data analysis for testing. So that's my year-long project this year. And then once I graduate in May, I hope to teach high school math in the DFW area. So wherever that leads me.